Hello, chemistry students. Today we're going to talk about the combined gas law. Now here we have Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's law, and we are going to combine all four of those laws into one law called the combined gas law. Now if we look at Boyle's law and Charles' law and we superimpose them, you'll see that P1 times V1 divided by T1 is equal to P2 times V2 divided by T2. And part of that, the P1 divided by T1 is equal to P2 divided by T2, gets rid of the Gay-Lussac's law. So we have just combined three of the laws. And then we're left with Avogadro's law. V1 divided by N1 is equal to V2 divided by N2. Now if we superimpose those two, sorry, they're not perfect, we have P1 times V1 divided by N1 times T1 is equal to P2 times V2 divided by N2 times T2, and that is the combined gas law. Now let's do an example calculation. So what would be the volume in liters of an 8.9 liter sample of a gas at 100 degrees C and 113 kilopascals if conditions were changed to STP? Now remember, STP is standard temperature and pressure, and standard temperature is 0 degrees C, and standard pressure is 1 atmosphere. I'd also like for you to remember that the ones in these calculations and these laws stand for the initial conditions. So P1 would be the initial pressure or starting pressure, and V1 would be the initial volume or starting volume. And the 2's stand for the final pressure, volume, moles, and temperatures, or the endings. So P2 would be the final pressure, and V2 would be the final volume. So let's write down our data. Here we've got 8.9 liter sample, and that is our initial volume. And it's at 100 degrees C, so that is our initial temperature. And remember, all of our gas laws have to be in Kelvin, so we might as well go ahead and convert that Celsius into Kelvin, which is just 373 Kelvin. And our initial pressure is 113 kilopascals. All right, now it says that the conditions were changed to STP, standard temperature and pressure, and we are looking for volume. So our final volume is what we're looking for, so that's a question mark. Our final temperature is 0 degrees C, so we're going to go ahead and convert that to Kelvin, which is 273 Kelvin. And our final pressure is 1 atmosphere. Now, this should be a clue right here. We have our initial pressure in kilopascals and our final pressure. Those should be finals, I apologize. Our P2 is in atmospheres. We need to convert that to kilopascals or convert our kilopascals to atmospheres. Well, I think it's easier to convert 1 atmosphere to kilopascals. Let's look on our STAR reference sheet, and we notice that 1 atmosphere is equal to 101.3 kilopascals. So now let's go ahead and plug all these things into our formula. But before we do that, we need to rearrange our formula. Okay, now let's rearrange our equation right here to look like what we're looking for. So we're looking for the second volume, or the final volume, or V2. So we need to rearrange this formula to where it looks like V2 equals, and then move everything else to the other side of the equation. So I'm going to rewrite this, and then P1 times V1 divided by N1 times T1. That equals P2 times V2 is divided by N2 times T2. Now if you notice, we don't have any moles over here in our problem. So if moles are not mentioned, you assume that they stay constant, and if they're constant, you can get rid of them. They cancel out on each side of the equation. So now we have P1 times V1 divided by T1 is equal to P2 times V2 divided by T2. We need to move the P2 and the T2 to the other side of the equation. Now, how we do that is we look at each variable and determine how it is related to the variable that we want to keep. So we want to keep V2 on this side of the equation, and the P2 is multiplied by that. So in order to move it to the other side, we have to do the opposite. We have to divide. So that's what we're going to do. We're going to divide by P2. Whatever we do on the right side of the equation, we have to do on the left side of the equation. So we're going to divide both sides by P2. That makes P2 divided by P2. They go away. They cancel. And now I'm left with T2 that I need to move on the other side. I look at T2 in relation to the variable that I want to keep on this side, which is V2, and they are divided by each other. So the opposite of division is multiplication, so I'm going to multiply each side by T2. And a T2 divided by a T2 cancels each other, so they go away. And I am left with my formula V2 is equal to T2 times P1 times V1 divided by P2 times T1. Now I'm just going to plug all that in. I've got V2 is equal to T2, which is the second temperature, so I'm going to go down here and I'm going to do 273 Kelvin. And I'm going to multiply that by the initial pressure, and that is 113 kilopascals, times the initial volume, which is 8.90 liters. And I'm going to divide that by P2, which is the final pressure, which is 101.3 kilopascals, times T1, which is the initial temperature, which is 373 Kelvin. Now I'm going to start canceling out my units. I've got a K on top and a K on bottom, so they go away. They cancel out. I have a kilopascals on top and a kilopascals on bottom, so they cancel out. And I'm left with liters, which means my new volume is going to have the units of liters. So 273 times 113 times 8.9 divided by 101.3 times 373 equals 7.26 liters. So our new volume is 7.26 liters. Thanks for watching.